Hi, everyone. Our group chose to research and evaluate information on cancer and its relation to lifestyle, specifically diet, obesity, and stress. My name is Alejandra Castro.
And my name is Dariana Abascal.
I'm Andy Sharoff.
Hi, I'm Amanda Bermudez.
So, lifestyle is something that most of us think about every day, whether it's food we eat, how active we are, or how we deal with stress. While cancer can be influenced by genetics, research has shown that many lifestyle factors can play an important role in cancer risk and even progression. Before we go into the research findings, I'll start by introducing what cancer is and why these lifestyle factors are important. You can go to the next slide. So, to begin, it's important to understand what cancer is. Cancer is a disease that occurs when some cells in the body begin growing uncontrollably instead of following the normal processes that regulate cell growth and division. These abnormal cells can evade nearby tissues and eventually spread to other parts of the body through a process called metastasis. Because of its ability to spread and disrupt normal organ function, cancer can be very deadly. So, as you can see here, we have the characteristics of cancer cells. So there's several characteristics that distinguish cancer cells from normal cells. So unlike healthy cells, cancer cells don't use regular signaling to tell them to grow. They also ignore the signals that would normally stop cells from dividing. One of the main processes that they ignore is apoptosis, which is the programmed cell death. Cancer cells also stimulate the growth of new blood vessels, which is called angiogenesis. And these blood vessels give tumors oxygen and nutrients, which allows them to grow and spread very quickly. Additionally, cancer cells can evade the immune system, accumulate genetic mutations over time, and even change the way they use energy to support rapid growth. And you can see here on the picture to the right, you can see the normal mitosis versus the cancer cell mitosis. You can go to the next slide. So, although genetics certainly contributes to the cancer development, they're only part of the picture. Our daily habits affect many of the biological processes involved in cancer development. For example, diet, obesity, and chronic stress can influence inflammation, hormone regulation, immune function, and DNA damage. When these processes are disrupted over long periods of time, they can create conditions that make cancer more likely to develop and progress even quicker. So the image on the left demonstrates this idea. In recent decades, rates of obesity have risen dramatically worldwide, alongside an increase in the consumption of highly processed and calorie-dense foods. So as you can see, it shows that diets that are high in processed foods and unhealthy fats are associated with chronic inflammation and metabolic dysregulation, which leads to cancer genesis and cancer progression. On the other hand, a low-fat diet increases metabolism, and the anti-inflammatory and antioxidant compounds also help for cancer to be prevented and inhibit the cancer. It's also important that not every cancer is preventable. However, adopting healthier lifestyles has been shown to reduce the risk of several types of cancer. You go to the next slide. So here we can look at key statistics that prove these points. So in the United States, about 2 million new cancer cases are expected to be diagnosed in 2026, with more than 600,000 cancer-related deaths are predicted. Researchers also estimate that approximately 15 to 20% of cancers could potentially be prevented through healthy lifestyle behaviors. Additionally, diet itself is believed to contribute to nearly 30% of cancer-related deaths, and certain groups are disproportionately affected. More than 90% of obesity-related cancers occur in adults over the age of 50, and women are also at increased risk for several obesity-related cancers, like postmenopausal breast cancer, endometrial cancer, and ovarian cancer. You can go to the next slide. So our presentation focuses on three major lifestyle factors that have been consistently linked to cancer, which are diet, obesity, and chronic stress. So for diet, it influences inflammation, affects hormone regulation, and could increase the risk of cancer. Secondly, obesity is associated with at least 13 different types of cancer. So this excess fat tissue promotes chronic inflammation and alters the hormone levels as well. And it basically creates an environment that supports the tumor development. And for chronic stress, it affects the immune system and the endocrine system, which increases hormones like cortisol, and which could lower your immune system and have more cancer cells attack. Now that we've established this relationship between lifestyle and cancer, I'll hand it over to Andy so we can continue discussing the link between diet and cancer.
Next slide. All right, so now we're going to give a literature review between these different things that we've discussed and how they correlate to cancer. So the first link we're going to be discussing is between diet and cancer. So the strongest correlation between them in terms of diet has to do with red and processed meat, and then it usually causes colorectal cancer. So there's a well-established link between these types of meats and this specific type of cancer, as many studies have been like done on it previously. So the data shows that for every 50 grams of processed meat consumed daily, there's an 18% higher risk of developing colorectal cancer. So studies have also found significant rise in colon cancer risk among people with high red meat intake. So what's important to realize here is that the association is seen with red and processed meat causing colorectal cancer, but not white meat. So that means that something present in the red meat and the processed meat has to be driving the cancer, but it can't be present in the white meat, or else it'd also be causing this colorectal cancer. And so the thing that was found to be causing these mutations inside of the colon and eventually leading to cancer was heme iron. And so on the next slide, I'm going to be discussing how exactly this heme iron causes these mutations. But it is important to note that there is also associations, although they're weaker, of stomach cancer, pancreatic cancer, and prostate cancer associated with red meat and processed meat as well. Next slide. All right, so heme iron drives cancer through two separate pathways, both of which damage DNA. So the first pathway is the formation of N-nitrosyl compounds. So heme promotes a reaction that produces these compounds, which bind to DNA in the colon and form damage sites known as DNA adducts. And then the second pathway is the lipid peroxidation. This is where heme generates free radicals and reactive lipid products, also damage the DNA. And so when this DNA damage is not repaired, it causes mutations in three specific genes, and that's the APC, the P53, and the KRAS genes. And from studies in colon tumors, we've seen that these, like all the colon tumors have mutations within these three genes. So we know and they also initiate the colorectal cancer. So we know that mutations in these three genes play a big role in causing this kind of cancer. And since these two pathways play a role in mutating these genes, we know they're like an initial activator for cells that could potentially become cancerous. So there is a good side to this, or a positive side that may block the effects. And so as you can see in the diagram to the left, they have to be catalyzed, the heme and the nitrosyl heme. They have to be catalyzed in order to produce the reactants that eventually lead to the mutation. And there is a way to block this catalyst or catalytic effect, and it's through calcium, chlorophyll, and vitamin C and D. And we find the calcium, chlorophyll, and vitamin C and D primarily in fruits and vegetables, which is why it's highly advertised to eat fruits and vegetables, because they lower our risk of developing colorectal cancer, even if we are eating red meat or processed meat. Next slide. All right, so we're going to be discussing the link between obesity and cancer. So what stands out about this link is how many different kinds of cancers it affects. So previously we were talking about the diet and we were mainly talking about colon cancer. In this case, when we're talking about obesity, there's 13 different cancers associated with it, as you can see in the diagram on the left. And so what happens is excess body fat raises cancer risk across a wide range of cancers, and this risk increases as body weight increases. So a large study estimates that overweight and obese people may account for about 14% of cancer deaths in men and about 20% in women. So the reason that the cancer rates are higher in women is because these cancers include endometrial and postmenopausal breast cancer. And so for endometrial cancer specifically, women with obesity have roughly 2 to 4 times the risk. And then age is also a major factor that plays into developing cancer in these cases, with more than 90% of these cancers occurring in adults over 50 years old. So the burden with obesity and cancer most heavily falls on older adults and more heavily on women, but it is important to watch our weight in order to prevent these causes. And so now we're going to be moving on to how the obesity actually leads to the development of cancer. Next slide. Okay, so it's important to note that fat tissue is not just passive storage. So it behaves like an active organ that drives cancer through three separate mechanisms. So the first one we're going to be discussing is insulin, and that's the one that's mainly shown on the diagram to the left. That's the pathway for it. So what happens is excess fat makes the body resistant to insulin, so it produces more of it on its own. And so high insulin raises levels of a growth factor called IGF-1. And this IGF-1 promotes cell growth and prevents cells from dying off normally. And then that uncontrolled growth and it not being able to perform apoptosis on its own is the basis of cancer. So the second pathway that obesity leads to cancer is through hormones. So fat tissue contains an enzyme called aromatase that converts other hormones into estrogen. So more fat tissue means more estrogen, and that excess estrogen fuels cancers like endometrial and postmenopausal breast cancer. So this is the direct link to why women are affected more. And then the third pathway is chronic inflammation. So enlarged fat cells release inflammatory signals called TNF alpha and IL-6, which keep cancer cells alive and help tumors build their own blood supply. So excess fat acts on the body through three pathways at once: growth signals, hormones, and inflammation. Next slide. So the third environmental factor that leads to cancer that we're going to be discussing is stress, um, more specifically chronic stress. So stress is usually thought of as purely mental, but research shows it produces real physical changes in the body that can promote cancer. So there was a study that was conducted, and they used a mouse model of ovarian cancer. And so researchers compared a group under chronic stress against a calm control group and measured what happened to the tumors. The results showed that the stressed animals developed larger tumors with more aggressive and invasive growth, along with higher levels of stress hormones in their tissue. So as shown in the panel below, we can see that the stress mice have 2 to 3 times the tumor weight and several times more nodules than the control group. So this raised like the central question of the study, which is how stress is able to reach inside a tumor and change how it grows. So in the next slide, we're going to be discussing the mechanism for how stress actually leads to these tumors growing so much and, you know, having that effect. Next slide. All right. So under chronic stress, the body releases stress hormones called catecholamines, and the main one is norepinephrine. I'm sure you've all heard of that. So norepinephrine binds to the beta-2 adrenergic receptor on tumor cells, which activates the CAMP and protein kinase A signaling pathways inside the cell. So that pathway increases production of VEGF, which is the protein that builds new blood vessels. And so more blood vessels and access to these blood vessels allow the tumor to be fed and to keep growing and spreading. So when cells were exposed to norepinephrine, VEGF activity increased by about 1,240%. And that effect was blocked entirely by propranolol, a common beta blocker, which you can see in this panel on the left. Yeah, where stress plus the propranolol resembles the control group. So the effect also did not occur in cells that lack the receptor. So this confirms that the beta 2 receptor is the driver for this growth in the tumor cells. So this is a classic stress and cancer pathway working through the adrenergic signaling. And more recent research has since uncovered an entirely different route that stress uses to promote cancer, this time through the gut bacteria, which we'll look at next. Next slide.
All right, thank you, Andy. So like Andy was saying, there has been a new research finding that demonstrates how stress nourishes cancer. And the way that is connected is through gut bacteria. And before we go more in depth about it, I would like to show this diagram. And the main thesis is that the mental stress accelerates the growth of cancer by forcing gut bacteria towards it. So what does that mean? It's just stress overall is not just mentally that it affects our body, but nowadays it's even physiologically. And we see here in this diagram, if we look to the top corner on the left, we see that it affects an anatomical perspective. So if you see the three red dots, this is chronic unpredictable mild stress, which enters through here. And then eventually it's going to lead to the bloodstream and then goes back to the tumor. And we're going to see how does that affect the B cell. And then from this point of view, if you see on the bottom, we see how it affects from the cellular environment once it does enter inside the tumor. And the way how it affects it, we see that I would like to say it in a way that it builds up like an armor, like a shield against to receiving the actual antibodies to defend any growth or to accelerate to prevent any growth for the tumor. So analogy before I would like to continue as well to make it easier. I'm going to explain it more on the next slide, actually. So let's just continue forward. So phase one, stress hormones rupture the intestines lining. So like I said, I wanted to do like a little analogy beforehand. So imagine the gut lining and the stress, the invaders, the tumor, and the deception. So imagine a castle scenario. So the gut lining would be the fence around the castle and it defends you and it keeps the good knights, like the healthy cells inside. But then stress comes and invade that territory and it conquers the castle fences, making them very weak and fragile. And once the invaders come in, the walls crack and then the bacteria, it slips through. So I guess imagine it as like spies from the enemy, and then the tumor, once the enemy spies, they enter into the base inside the castle, the germs sneak towards the base. And once the inside the enemy base, the harmful germs acts like inside agents. They manipulate your body into making more stress hormones. And then this eventually makes your immune system shuts down and the tumor grows in a rapid manner. And in this research, we see exactly that, how in the period of 21 days, and we also did use a mouse model for this one. It elevates the blood plasma, the corticosterone, from 70 ng over ml in controls to 240 ng over ml. The molecular mechanism in this case scenario is that stress hormones merges to the NR3C1 nuclear receptors in the intestines, causing a rupture, like I said, in the vital proteins that assures a closed gut. So that is the way how eventually bacteria is giving access to enter through via bloodstream is because the gut is broken. And so then it shifts back to the tumor, and we could see the results over here in the data as well on the bottom. And I'm going to continue forward to phase 2 now. Now, phase 2 is the armor that I was explaining on the first slide, the intratumoral immune armor. So we also observe here in this research that cancer creates an area of blockage against B cells and eliminates any anti-tumor antibodies, which permits the growth of the tumor. The quantitative data, as we see on the bottom, the intratumoral corticosterone duplicated by twofold, leading a disastrous collapse by 85% in GCB cells. So that is the explanation on why, there is a lot of suppression against the immune system, because like I said, the healthy cells, the white blood cells that usually would go against cancer, are being affected by stress. And then the molecular mechanism in this case scenario is the same bacteria that we were talking beforehand. The EG bacteria in the tumor distributes phage DNA that triggers TLR9 receptors within CAFs, pressuring them to make stress hormones that halt anti-tumor B cells. And we shall continue to the next slide, which would be the last phase. And I guess this would be demonstrating the solution once we are aware what is causing the shutdown for the healthy cells and the acceleration of the tumor growth. So removing the intratumoral immune armor. Observation. Obstructing the stress trajectory destroys the tumor's armor, permitting now B cells to penetrate the tumor and cancel the escalated growth. So we're finally, once we're allowing access again for the healthy cells to take over by the treatment. And we see this in the quantitative data, the drastic change that there is seen. The therapy saves GCB cells back to their regular selves. The decrease of ultimate tumor volume was by 50%. And the molecular mechanism here in this, it would be wiping away all the bacteria with antibiotics, or hindering TLR9 receptors in CAFs, which halt stress hormones, allowing B cell NR3C1 to function back to normal. So we notice if we do not allow access for stress hormones to take control of the tumor, and we use substances such as antibiotics and TLR9 receptors, then it does do an impact overall for tumors. And we can see this in the figure G on the left corner here on the bottom with the controls and with the COMS isotype. And then on the right corner, we also see the same thing. And overall, this is from my part for the research finding on how stress affects overall cancer. And I will be giving space for Amanda to keep on speaking about our presentation.
Hello, everybody. We can move to the next slide. I'm Amanda Bermudez. Okay, so I will be talking about the link between dietary sugar and cancer. So you ever notice whenever you eat tons of sugar, you get the sugar crash effect. So because of the sugar crash effect, you have no dietary fiber, there's nothing to slow it down, leading to a increase in your blood sugar through your bloodstream. That's the word blood crash, because your pancreas would pump out large amounts of insulin And whenever the result of your sugar plummets, it'll send an energy message to your brain. Oh my God, hey, you need to eat. So like you're hungry again. So constantly eating large amounts of high refined sugar or any sort of like processed food, junk food. I will not lie, I ate a whole pint of ice cream yesterday and I was hungry afterward because I didn't have anything to satiate myself fully. So leading to a hunger spike of refined sugar. So your body needs more for you to feel full enough so that way you don't keep eating sugar after sugar. So in the large intakes of processed foods, a high sugar found to be linked to higher incidence of pancreatic cancer, breast cancer within premenopausal women, liver, biliary tract cancer, or colorectal cancer. And because of this large amounts of leptin, which is a saturated hormone level, it can activate the HAK or STAT and MPAK pathways. And with the high level of leptin, promote cancer migration, invasion, and epithelial to meniscus chimal translation allows the tumor cells to permeate to allow to other cells, allowing the cancer to enlarge and to send the tumors become larger. And through your body, as sugar undergoes change into glucose, the body uses it as its primary source of energy. So does cancer in tumor cells. Cancer cells require a large amount of energy and glucose by taking it through pyruvate. And through pyruvate, it goes into fructose. And fructose stimulates the spread and growth of cancer cells by the Warburg effect, as seen right here and in photo. Okay. And the concept of the photo is how cells eat compared to normal cells. They will use more sugar to allow themselves to have growth and spread. And they have a different metabolism to fuel the rapid growth, even when they have tons of oxygen plentiful. Okay, now we can move on to the next slide. Okay, and by the reduction and elimination of sugar in our diets, it can lower our chances of developing several numerous cancers or tumor growths. High fructose corn syrup is the most common link to obesity in America at this current moment, which can lead heart disease, which is the number one leading cause next to cancer. The reduction of full or quit sugars in our diet can affect our prevention and growth of cancer. A diet that is rich in fruit and vegetables can protect us against said cancer or cardiovascular diseases. Reduction of high processed food can reduce cancers such as breast, pancreatic, endometrial, cholesterol, liver, and biliary tract. The impact of reducing sugar for colorectal cancer is it restores a gut healthy microbiota, which limits mucosal cell proliferation. And for breast and abdominal cancer, reducing the sugar, it lowers our overall body fat, lowering hormone levels that drive the tumors. And pancreatic cancer, reducing the sugar can reduce our pancreatic overload, giving our pancreatic a break, and it migrates local insulin, drive growth. And liver and biliary tract, by reducing the amount of sugar, it prevents non-alcoholic fatty liver and halts progression to cirrhosis and cancer. And dietary fiber slow glucose absorption, which prevents our blood sugar from spiking, such as GLP-1 pathway and PYY pathways. Okay. And right from the ANL 2024 reading article, back to as a little girl. Okay. we see in middle age participates from Spain persistent consumption of sweetened sugar beverages or linked to a higher incidence of breast cancer against postmenopausal women, which just suggests that our sugar intake does affect cancer later on within our lives. Okay, we can go next. Okay, and how intermittent fasting can help us against cancer. Intermittent fasting can reduce our risk for cancer or tumor growth. Fasting, we can deprive cancer cells of glucose via the Warburg effect. We cut off their main energy source and drop our blood glucose levels. Cancer cells are a osogenic mutation. By cutting off glucose, they run out of energy, which means they're no more viable to grow, putting them at risk to oxidative stress and immune attacks. Okay, our healthier cells will go into a protective shield mode where they will stop dividing and focus all of their on DNA repair, maintenance, and making them highly resistant to toxicity against other cells that are no longer healthy. Okay, and it trains our NK cells or natural killer cells to become proficient at clearing off tumors and cancer cells. And during a fast, autography kicks into a deep cellular cleave mode. So healthy cells will break down and recycle ditch mitochondria, faulty proteins. Yeah. You're good.
So to conclude, cancer is a complex disease that develops through both genetic and environmental influences. And we saw consistencies in our presentation that diet, obesity, and chronic stress affect the body in different ways, but they all share common pathways such as chronic inflammation, hormonal changes, immune suppression, and DNA damage that can promote cancer development and the progression. One important point is that lifestyle is only part of the puzzle. Making healthy choices doesn't guarantee that someone will never develop cancer. And developing cancer doesn't mean something caused it through their lifestyle. However, research consistently shows that maintaining a healthy diet, staying physically active, keeping a healthy weight, and managing chronic stress can lower the risk of many cancers and improve overall health. Thank you. And these are the differences.
Thank you.